All right, welcome to Tradecraft Tuesday. We are your hosts. I'm Chris Bisnett, and this is Kyle Hanselman. Yeah. So we wanted to make sort of a video podcast about malware and stuff. And we like the Blab platform. It sounds really interesting because we can actually get real-time feedback and questions from viewers like you. So. This is episode 2. Last week, you probably missed it. It was episode 1 at Spectacular Fail. Did not go so well. But hopefully we have everything worked out for this time.
Something about tethering in your car doesn't work, mobile platforms, all kinds of fail.
Yeah. So obviously, for those of you who are currently watching, you know that Tradecraft Tuesday happens every Tuesday at noon. And this is where we'll have it. You can usually find the link. We'll post it on Twitter, so you can find it from there. So, Kyle, do you want to talk a little bit about yourself and your credentials?
Yeah. So my background, I've been in offensive cybersecurity for about 10 years professionally. As a kid, I guess I was a skid like most of us. I grew up breaking things on AOL. Through that time, I learned how to program, learned how to reverse, got into malware analysis, one capture the flag once. And that's kind of brought me to where we're at now.
Yeah. So pretty similar. I have a background, a lot of reverse engineering, a lot of vulnerability discovery. I teach a fuzzing class at Black Hat every year. So I don't have a huge background in malware reversing. Mostly my reversing was for the purpose of finding bugs and stuff. So but I mean, reversing is reversing. So I think it all applies. So if you did happen to see last week's, you'll know that last week was kind of, because of the epic fail, there was just really no format. It was just kind of like rambling, talking. I think Kyle talked with Rob Fuller about, I don't even know, InfoSec policies or something.
Yeah, that's exactly where it went to. I see Rob's actually on board now.
Yeah. So this week we're going to actually try to have a real format. So we're going to try this new format of like 30-minute discussion. We're going to try to do a full-length 30-minute. The beginning part, kind of a discussion of some malware that we picked. Why is it interesting? How does it apply? How do you find it? And then finish it up with questions from viewers. So let's go ahead. Kyle, you want to introduce the malware that we're picked for this week?
Yeah, with that in mind, I'll start real quick with, it's called Tradecraft Tuesday for a reason. And it has to do with the offensive tradecraft or even the defensive tradecraft that's used to counter some of these adversary actions. The reason I find tradecraft so important is it's constantly changing. It's the tactics, techniques, and procedures used to go about, the offensive business. And at the same time, we have to adapt as defenders to be able to counter these. This particular sample, which is called Poweliks or Poweliks, depending which vendor you're looking at, I found it very interesting because it showed new tradecraft. And more specifically, it showed tradecraft on how it was going about command execution. Its persistence was kind of novel, and some of its evasion techniques. So in case you guys haven't seen, I'll throw the link right down below in the chat out to everybody. But this is the blog that I'm referencing. Chris, with that said, I know that you and I are both familiar with Poweliks, but the idea behind it, this was a lovely malware sample that was interesting behind it is after it infected the initial computers. It wasn't exactly easy to see if you were just using something like autoruns or some of the typical tools if you're looking for persistence. On top of it, it actually had some really neat parsing functionality that they really abused, essentially some command line capabilities and some fallbacks, and I wanted to draw attention to those.
Yeah, definitely. Let's get into, I guess, the techniques more specifically. So, like Kyle said, for anybody who hasn't actually read the write-up, the post is in chat. The link is also on our Twitter. There's several write-ups, but this is the one that we thought was probably the best. Didn't glaze over anything.
So I'm posting real quick. The first technique I'd like to call out is I just find it really interesting how they abuse RunDLL32 as well as calling the exported function RunHTMLApplication from the mshtml.exe. I know that's a mouthful real quick, but I'll post what I mean here in just 1 second. That way we can share it with everybody. Sweet victory. My proof of concept is working. So real quick, inside our chat, I just posted a snippet that looks like a typical run DLL 32 call. And so how run DLL works, it's essentially a host application, which will load up your DLL and call the ordinal or the exported function. And what's neat about this is this particular adversary appears to have used this for, maybe some heuristic evasion. The idea behind it is they were trying to get some code working. So what I just pasted here is, it looks like a giant, long, ridiculous string. But what's neat about it, it uses the JavaScript engine within the mshtml DLL to execute the JavaScript code. So Chris, have you seen anything like that before? That actually, I've seen plenty of stuff use run DLL 32 to call functions, but have you seen anything that abuses mshtml like this before, Poweliks?
No, definitely not like this. Like you said, it's really common to see run DLL 32 and use some DLL, and I think a lot of the reason behind that is it kind of tricks antivirus, right? Antivirus is going to check out that key and they're going to see run DLL 32 and say, okay, we've seen that before. That's a Microsoft binary. It's safe. And unless the vendors actually put in a lot of effort to say, okay, let's try and parse the run DLL 32 arguments, figure out what the DLL is, and then scan that DLL, they're going to miss it. But in this case, they've taken it one step further. They really have completely abused a lot of the underlying Windows concepts for how they load DLLs, how they determine which entry point to call, and then married that up with mshtml and their protocol handlers to, execute JavaScript in the context of Internet Explorer, which gives you a lot of things, right? You get all of the permissions that Internet Explorer has. You're going to run as a moderate level process, so you can do things over the network. You can use WebSockets. You can hit local files. The proxy will already be set up for you. A lot of the really difficult heavy lifting that a lot of malware has to do to make sure that they can get comms to the internet is already done because, everyone needs to use Internet Explorer apparently. Yeah,
network access control as well that's saying, hey, only these trusted processes should be able to communicate out to the network. This is going to fly right by in the sense of, mshtml being trusted within a process. Going back real quick, Chris pointed out a real interesting point about most antivirus that parses, maybe it's going to fall for something like a signed executable. I feel that a lot of AV vendors are coming around and realize that run DLL 32 and should not be inherently trusted. But the most extensive parsing I've seen tends to usually stop at, is this a trusted application or a trusted DLL that's being called? And what's really interesting about this is not run DLL 32 calling, shady unsigned DLL from the attacker. This is straight up using lots of redirection and failover to call a legitimately signed Microsoft DLL. And that's important for distinguishing there because that's just tradecraft that we haven't seen before. It really puts the onus on the AV vendor to really know what they're doing. And I think a lot of this time, we probably just blow right past any heuristics.
Yeah. So we posted a command line down there that you could use as kind of a demo just to see it out. But let's go ahead and actually step through how run DLL 32 parses this and how we get to JavaScript execution.
Chris, now that we have a couple more people on board, do we want to open maybe initial questions, assuming we've kind of done a lot of assumptions. We don't really know much about our target audience. Does anybody have any questions for us? I see there's 5 or 6 people already on board. We've got an open seat here if anybody wants to join and verbally chat it out with us. 5, 4,
Anybody?
3, 2,
Anybody?
1. All right.
Okay.
I'll assume we're hitting the target audience correctly.
All right. So if you have any questions, just hit the call in button and you can get on here and ask it. So all right, I'm going to go ahead and I'm going to step through basically how all this long string becomes executing JavaScript. So the first thing that's going to be done is run DLL 32 is going to be called. And for anybody who doesn't know, run DLL 32 is kind of just a little wrapper that allows you to load up a DLL and call some function. It seems like originally maybe it was used for testing purposes, like way back in the day, Windows 3.1, Windows 95 days. But it's just been left around and people started to use it. So I think Microsoft actually can't go back and take it out. Usefulness of it is somewhat limited depending on what parameters you need to pass to a DLL, but if it can take and parse a command line argument, you can do a lot with it. So the format of the parameters to run DLL32 is the name of the DLL, followed by a comma, no space, followed by the name of the entry point function. And then that's followed by a space, followed by any arguments you want to pass to that DLL. And so what run DLL32 will do is go ahead and it will parse the first argument to it. It looks for the comma. Anything before the comma, it treats as the DLL name. Anything after the comma up to the first space, it will treat as the name of the entry point function. And then what it will do is it will call load library on that DLL, and then it will call get proc adder to get the function address from its name, and then it will call that. So one of the things being abused here is that the way it finds the DLL name is just by looking for the comma. So it will skip past all that JavaScript colon, quotes, // all of that. It finds the comma, and then it finds a space. And so you end up with two parts here, one part that starts with JavaScript and one part that's RunHTMLApplication. And then what ends up happening is they try to look up the attributes to that file, and that will fail repeatedly. But they just continue on and they call load library on it. And what load library will do is it will actually append .dll to the name of the file if you don't have it. You can actually call load library on things that don't have .dll. You can load library on .exe, on literally any extension. But if there's no extension to the name, it will add it. So once it does that, load library goes and it looks through the safe search path, which really only applies to Windows XP and I think Vista. And what the safe search path did, it was a patch to Windows where Microsoft tried to mitigate some DLL hijacking stuff. So they changed the path order where Windows will search to find the DLL. And once it starts looking for it, it goes ahead and it parses it as a path, and it sees // And for anybody who's familiar with any use of the command line, you'll know that means parent directory. So when it canonicalizes the path name, it sees the parent directory, and so it just drops off the first preceding thing ahead of that, which happens to be, in this case, JavaScript colon and a quote. So if this were home, Chris, foo, it would basically drop off anything. So if you had home, Chris, foo, // thing, it's going to drop foo, and you'd end up with home, Chris thing. Hopefully that makes sense. If it doesn't make too much sense, go check out the blog post. They have images and stuff.
And I do my best to document some of the actual blog settings here to kind of reiterate what you're hitting home with.
Okay. So basically that finds the DLL, mshtml, in C Windows System 32, loads it up, calls get proc adder on RunHTMLApplication, and it passes in the command line. And based on what we talked about, run DLL32, the command line that's passed to the DLL is only the last part. It's anything after the space following the entry point name. So in this case, they only get this last part, quote, semicolon, alert, TradecraftTuesday, close parens, semicolon. So initially you would say, oh, that doesn't look right. It has like this quote. There's a missing quote at the end. That's not valid JavaScript. That's not going to execute. Well, one of the benefits that the attackers found with this is that RunHTMLApplication does not care what run DLL32 gave it. It calls a function to get the original command line and then parses it itself. So once it gets the original command line, it drops off run DLL32, and the full command line ends up being JavaScript colon followed by everything else.
And that right there alone is a really interesting indicator about the level of sophistication for the adversary. I mean, this isn't somebody who just stumbled onto a cute idea here. This is somebody who took the time to actually reverse to understand not only how this function should work appropriately, but how it should fail, which is pretty interesting. A tidbit that you can pull away from maybe the future activity you'll see from this actor.
Yeah, definitely whoever did this knew the intricacies of loading DLLs and also running HTML applications, because if you don't know the very specific details of how they treat each argument, you wouldn't be able to come up with this. The average person looking at this would say, like, this doesn't make sense. It's not going to work. This doesn't make sense. But due to some backwards compatibility hacks and stuff, a lot of this does work. So the reason that JavaScript gets executed is via these protocol handlers. So there's a protocol handler for a bunch of different things installed by default into IE. So you have HTTP : HTTPS : file : and in this case you have JavaScript : and that basically pulls up a class ID, and then they pass it to the thing and say, okay, go ahead and run this. So you could see the exact same thing by just, if you in your browser just truncate off the prefix of run-DLL32 and copy the rest of it, JavaScript : right into the URL bar, hit enter, you'll see a pop-up that says TradecraftTuesday. So that's pretty much how it works. Once they're executing JavaScript, there won't be a window, and they can do whatever they want to the local file system, and like we said before, access the internet.
What's interesting about this piece of malware for the functionality is not only was it novel, it's flexible. So this actor on top of it, for Poweliks, they actually embedded it within the registry and hid it behind a null terminator. The null terminator was interesting because it made it not initially viewable in tools like regedit, who just stopped parsing at the null terminator. However, other actors that picked up this capability, I think it was Kovter, Kovter, and those actors kidnapped this exact same functionality, but pulled out the need for the dependence on the registry and the loading of it via fileless, from the registry directly, yet still kidnapped the ability to use JavaScript to execute new functionality. And so I see this piece of Tradecraft being extremely flexible. Like, it may be somewhat signaturable per se, but I see there's a lot of room to be able to repurpose this capability. I imagine we'll continue seeing more and more malware reuse this. I don't see why not. Because from what I've seen on the initial signatures of this malware itself, is people aren't grabbing it based off this piece of Tradecraft alone. So it would seem, highly likely, whether a red team member or maybe a defensive actor, or hell, even somebody conducting offensive cyber operations. But why not use this Tradecraft? It's going to be here for a while. mshtml has been around in Windows forever. I guess I could spin up a VM and see just how far back this goes, but it wouldn't surprise me if this goes back all the way till probably 2000 at least. Chris, any idea?
No, I don't know. I know that Internet Explorer has had the ability to run HTML applications for a long time, but I don't know how far back it goes.
Yeah.
But no, go ahead.
I was just going to say, if we get time during this, I'll pull it up. At the moment, I'm trying to find the links for Kovter to share with other folks of how this different actor has kidnapped the same functionality inspired by the actors behind Poweliks and kind of stepped up their game to have better techniques. And it's a great point.
Yeah. So I guess the real question is, if I'm a network administrator, how do I find this? How do I see if this is on any of the boxes in my network?
Ooh, that's going to be a rough one, because if you think about it, it's a combination. I mean, there's no reason somebody couldn't shovel this off with create process or something along those lines to execute on the actual box. We saw it used twice for persistence with both the malware that we talked about before. And then as for the actual, you mentioned as a network administrator, I mean, this might be rough, right? Enumerating, if somebody's calling it through run-DLL32, I mean, yeah, there's going to be the indicators that why is there a random run-DLL32 process, idling, especially if it's a blocking process they're calling, something like PowerShell that, launches an in-memory program. Is there anything else, Chris, that I'm missing right away? I know, this is going to be rough. Autoruns may detect it, but if it's hidden behind that null terminator, it's not going to see it. I don't think Autoruns has been updated yet by Mark.
Oh, it doesn't detect the null terminator?
I think it stops at the null terminator. At least it did. I haven't taken a look in the last 12 months to see what's changed since this technique actually came out.
Yeah. Interesting. I don't know. I think, gosh, I don't know. It's going to be difficult. I mean, I suppose you could write some scripts and put them in Active Directory to just dump out like using like the reg command, reg.exe, and dump out stuff and do like find stir to try to find anything with Run DLL 32 and JavaScript in it, and maybe then write to like a shared directory and say, okay, I found this thing here at this key, but how many run keys are you going to look through, right?
Yeah, if we were going signature based rather than heuristics based, one thing I noticed right away is they're not going to be able to get rid of JavaScript. I don't think they're even going to be able to, due to the way that it's matching against the protocol handlers there, I don't think they're going to be able to get away with obfuscating that word JavaScript. So maybe they can put something in, obfuscate the order. So it's not Run DLL and then immediately JavaScript, but definitely seeing JavaScript there in the command line. I can't think of too many reasons why you'd be passing a command. I mean,
right. It'd probably be a low false positive rate, I would guess. But I mean, it's not ideal if you're having to create, batch scripts and load them up into, to run whenever someone logs in. That's not really ideal.
Yeah, that's not ideal at all. What about from the viewing audience? Do we have any other questions? Anybody seen this in the wild or had to respond to this? I mean, I would not enjoy having to track this particular piece of software down. I'm even looking at the detections of how many AV actually find it, and it's still fairly minimal. And I imagine they're probably not signaturing on this particular piece of Tradecraft.
Yeah. Questions? No?
We got quiet. If not, we've got a little bit of time. Do you want to talk anything about, we kind of breezed over what a null terminator was. That's an interesting piece of Tradecraft that I don't get to see used enough.
Sure. So a lot of software is written in C still. Windows is still all in C. And what they'll do is they have what's called C-style strings. So for anybody not familiar with development, a string is just a text, right? It's ASCII characters. And the way they find the end of it is rather than storing some other separate field to denote the size, they'll store what they call a null byte at the end, or literally the character 0. So what happens is when programs will get a value back from the registry, they'll read the value, and a lot of times they'll do strlen on it, which is a common C library function which allows you to determine the length of the string. So if you do strlen on a value with a null terminator, it's going to count the number of characters up till that null terminator, and that's all it's going to tell you is there. However, the registry will store null terminators. It doesn't care. So in total, there could be 500 characters, but the 10th character could be a 0, and using C, if you're not careful, you'll only see 10 characters. So that's what Kyle's talking about when he says hiding stuff behind a null terminator. It's somewhat of limited use. In some cases, the thing that you're actually trying to get to parse your persistence mechanism is itself will only is limited by the null character, so you can't actually hide anything behind there. Although you could use that to store maybe configuration data or some other settings, and then you could read that from the registry. But a typical system administrator opening regedit or potentially even auto runs is not going to see any of that data.
Yeah, I was thinking right away, maybe crypto keys would be an interesting thing to stuff behind it. Maybe a malware ID or infected user ID, something like that. Those seem like logical things. On top of it, I've seen a lot of defenders start mentioning that, hey, there shouldn't be these large blobs of text in the registry. Like, there's never a real reason to have like a 5 meg base 64 encoded string within the registry. However, this might be a great way to defeat some of those capabilities. That if their parsing capability stops at the null terminator, it'd probably fall flat. On top of it, just to show the frustration, I posted a link to Bleeping Computer and those guys over there. Well, here's a user who's well aware that they're infected by Poweliks, but they're still ticked off that they can't go any further because of the null terminator, and they're having trouble removing the darn thing.
Oof. Ouch. Interesting. So if we don't have any guess we don't have any questions or whatever. I guess that's pretty much what we have, right?
Yeah.
You have anything else?
Yeah, I think this went well. Did anybody like the format or dislike the format? Any suggestions? I mean, we're on episode 2, so.
Yeah, we're definitely still learning, still trying to tweak things out, figure out what works best for us and what people are most interested in.
All right. Well, we got some hands ups from the audience, and with that said, I think that means this was a somewhat more successful run than episode 1.
Yeah, definitely. All right. So for Kyle, I'm Chris Bisnet, and peace out.
Oh, Rob's saying, "Ouch, dude! That wasn't your fault for episode 1. That was my fault, my friend."
Oh yes. Good thing we didn't record that one.
Yeah, no doubt. I was mumbling, rambling like now. All right, guys.
All right, later.
All right, thanks.